5.0, we're simplifying square roots and reviewing our exponent properties. So let's see, the opposite of a squared, like x squared, if we think about it, we take the square root of x squared, or it just equals x. So number one, we have square root of 100. And so one way that we can do this is just to break it down. We know that 10 times 10, right, that makes 100. So we have a pair. So there's actually an index here. There's a 2 there, but it's just assumed it's a square if there's nothing there. So there's 2 10s, and so this is a perfect 10. Number 2, we have square root of 45, so we can break that down. So that's 9 times 5, and then that's 3 times 3 times 5. And so that pair comes out as perfect. That comes out as a 3. 5 stays inside, so this is 3 root 5. Number 3, it depends on how you break it down. It doesn't matter how you do it. So 72, you probably think about 9 times 8 first of all. So that's 3 times 3. And then 8, hopefully you see that's 2 times 2 times 2. And so let's do that. So 8 just breaks down to 2 times 2 times 2. It's a square root, so we want to circle pairs of numbers. So it comes out as 3 and 2. And then whatever's left over inside is a 2. Now remember, when it comes out like this, you multiply them together, or you multiply to whatever is out there already. So this becomes 6 root 2. So that is simplified all the way. Now let's take a look at some exponent properties, reviewing some of these. So product of power property, to multiply powers with the same base, what we're going to do is we're going to add their exponents. We add the exponents and then we multiply the coefficients if they have it. So here's an example with numbers, so it's a little different. So we have 2 squared times 2 cubed. We could do the exponent, 2 squared, and then multiply the 2 to the third. But let's go ahead and use this property just to get some practice. So what we can simplify this is 2, and then you add the exponents, 2 plus 3. So that becomes 2 to the 5th power. And then remember, that's really 2 times 2 times 2 times 2 times 2. And that answer is 32. So here we have this example. We have 3x cubed times 2x to the 4th. So we can multiply the coefficients. So 3 times 2 is 6. And then we add the exponents. So this becomes 6x to the 7th power. Quotient of powers property. So when we divide powers with the same base, we're going to subtract their exponents. So if I write this out, 2 to the 7th, that's really 2 7 times. 1, 2, 3, 4, 5, 6, 7. And there's 2 to the 4th. 2 to the 4th means I have 2 4 times in the denominator. And so what I do is I cancel out the pairs. And so notice what I'm left with is 2 to the 3rd power. So really the shortcut to that is 2 to the 7 minus 4, which is 2 to the 3rd. That's the shortcut. Now let's take a look at this example here. So we have 5y to the 10th. So when we have numbers in the front, go ahead and divide those numbers or simplify. So I can divide 5 to the top and the bottom. And then so that becomes 1 over 2. So you divide or simplify the numbers. And then we can subtract the exponents. So y and then 10 minus 7. And then we don't really need the 1 there. So we can say y to the 3rd over 2. Power of a power property. So to find a power of a power, what you're going to do is we're going to multiply the exponents. So here, you just multiply the exponents together, -2 times -3, that becomes a positive 6, 2 to the 6. So that becomes 64. Now here, we need to be careful. We need to remember when you have a number inside, so 2w to the 12th. So we know that we're going to multiply the exponents. That is fine. But you also need to remember that that 3 belongs to that 2. So this becomes 2 to the 3rd, w to the 12 times 3. And 2 to the 3rd, that's not 6. So remember, that's 2 times 2 times 2. So that becomes 8w, and 12 times 3 is 36. So 8w to the 36. Powers of a quotient property. So to divide powers with the same base, still the same thing, we're going to subtract their exponents. So same as before. Now, when you see a cubed on the outside, what we can do is, remember that this 2 over 3, and raised to the third power means there's 3 of them. So one way to think about this is that it's 2 to the third over 3 to the third. Or think about just distributing it to the numerator and denominator, or distributing it to every single term inside, or every single value inside. So 2 to the third, right? So this is 2 to the third over 3 to the third. 2 to the third, that is 8, and 3 to the third is 27. So let's try this example here, x to the 5th over 2y to the 5th. So try it out, see if you can get it. Okay, so this is x to the 5th over 2 to the 5th and y to the 5th. So don't forget that 5th power also needs to go to the 2. So this simplifies to x to the 5th over 32y to the 5th. And that is done. Okay, 2 more. Negative exponents. Anything raised to the negative exponent it's going to move to the other side. So anything raised to the negative exponent moves to the other side of the fraction bar. Now, it's only what it's attached to, okay? So be very careful. In this case, this -3 goes to the entire value, this entire monomial, because it has a parentheses around it. So what we can do to simplify this is that we will write, it moves to the other side of the fraction bar, so this becomes 1 over 3x, and now it's raised to the third power. So now it's written as a positive exponent. So whenever working with exponents, it needs to be positive, and so you're going to move it, move whatever is attached to it. So now let's simplify this. 3 to the third power is 27, and then x to the third. So kind of using what we did in the other example. Now let's try this one. Look at it and see which one is the one that's going to move. Maybe circle the one that's going to move. It isn't going to be everything, to give you a hint. And so hopefully you circle the y to the -5th. That's the only one that moves. So 3 to the 4th is fine, it's positive. X to the 3rd is positive, so it stays there. So the y to the -5th is the only one that's going to move. So therefore, this is 3 to the 4th x cubed all over y to the 5th. And then we can simplify. 3 to the 4th is 81 x cubed and y to the 5th. Okay, so again, note that only the one that the -5 is attached to is going to move, not the whole thing. It only moves at the whole thing if there's a parenthesis around it, like this example. Now the last one, 0 exponents. Anything raised to the 0 power is, hopefully you said 1 and not 0. So anything raised to the 0 power is 1. And so in this case here, we have 8 cubed times x to the 5th times y to the 7th times z to the 4th, all raised to the 0 power. Now, if it's in a parentheses like this, like I don't need to distribute it. I just know everything inside, that's just going to be 1, and I'm done. Try this example on the right. What do you think that's going to be? All right, so this is similar to our negative exponents. So it only affects this here, only the x. It does not affect the 8. The 8 has a first power, and so therefore this is going to be 8 times 1. So the final answer for this is 8. So I hope this helped you out.